Assalamualaikum and hi, I am HAKIM. Now I will present a project of microcontroller application which is IoT car ESP32. So we are from group 2 and we have 4 members. First, which is me, IZZUL HAKIM bin SAMSAIFUL, CN200-222, and second members which is Muhammad AKMAL bin MUSA, CN289, and third, NURUL HIDAYAH binti RODZUAN, number metric AN200-222, and lastly, Paaventhan anak lelaki KUMARARAJA, CN200-179. So, in slide content, we have 9 chapters, which is first, description, design, block diagram, system flowchart, circuit diagram, programming, pictures of program, discussion, and lastly, conclusion.
Assalamualaikum, my name is HIDAYAH binti RODZUAN. I will explain the description of the project. This project aims to create a versatile and intelligent robot that can autonomously follow a black line on the floor. This robot can be controlled through a mobile phone application connected via IoT, which offer a seamless and user-friendly experience. The physical structure of the robot, including wheels, chassis, and a line-following mechanism, will be designed and built according to the desired specifications. The hardware components for these projects include a MCU microcontroller, a servo motor, 3 LEDs for indicating motor speed, and L298 motor driver for controlling the DC motors. A rechargeable battery 12 volt to power the motor driver, and a separate power supply such as power bank to provide stable 5 volt voltage for the MCU. Other than that, the blink components for the project include 4 buttons for controlling the motor movement, 4 LEDs to indicate the direction of the DC motors, 1 LED 5 to indicate the movement of the servo motor, 1 gauge to display the speed of the DC motors, and LCD to provide visual feedback on.
So this is our layout design. The layout design is shown here in multiple angles, including top, front, bottom, and side views. So the blue one here is the servo motor. There are 2 tires and then one 360 degrees tire. And the yellow box here is for the components and microcontroller.
Assalamualaikum and hi, I am Hakim. Now I will introduce about block diagram of our project. For our project, we use ESP32 for the microcontroller and Android apps user interface with 4 buttons connected with that have button 1, button 2, button 3, and button 4 to control the motor. While for the ESP32, powered by 5 volt power bank and battery, which is battery, and at the output we have motor driver L298, servo motor, and LED indicator on apps. While the motor, we use 2 DC motor, 5 volt, that powered by battery 12 volt. So that's all.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Okay. I will talk about system flowchart. Okay, as we can see in first process is when we turn on the system and the ESP32 will initialize and will connect to the Wi-Fi, and so it will initialize the blink, and then we can after connect to the blink, and we can check the system process in the blink, the button right, or the LED and the servo and the LCD, and after check the blink, and we and the system can go to the next stage by push the button forward, and the motor will go forward, and push button reverse and the robot will go reverse. But if we push button left, the motor will turn left, and the servo in the back of the car will turn left too. And by the button right, if we push, the car will be moved to the right and the servo will turn to the right. And also about the LED, the LED is the indicator to the speed. If the speed is low, and the yellow LED will light up and follow to the green and red. And red is the highest speed. If the car will turn the speed to the height, and the red LED will light up.
Alright, the coding is started with libraries, include Wi-Fi.h, and then Blink Simple for Blink, and then ESP servo motor is for the servo motor. It's all initialized, and then define Blink is for using the Blink app. If you don't have the if you don't include this Blink template, Blink template ID, Blink template name, and Blink authentication node token, you will not be able to connect to the Blink app. And next, your password and Wi-Fi ID and password, and then the pins for the components are initialized: servo, red LED, yellow LED, green LED, and so on. Then blink right before is for the speed gauge. So this coding is for the speed gauge. And then when update LCD, also when LED, next up is the LED indicator. If it's low than 120, red high; low than 170, yellow high; and then low than 225, green high. And then next up the then for blink right V0, it is for the forward button. So to move the car forward. So this it will, if button state is high, digital right and IN1 is high, and then IN1 also is high for to move both the DC motors. And then the LCD prints DC forward. Else it is all the DC the it is else it digital writes everything to low. There is also V0, V1 to move backwards, V V2 to move to the left, and V3 to move to the right. Then next up, the white setup. In white setup, debug console is serial begin 115200. So this is where the serial begins. Then the servo motor is initialized. Then all the pin mode is initialized. Pin mode for the motor driver. And then LED is also initialized. Then blink is connected to Wi-Fi. Then at white loop,
Hi, so this is our circuit diagram for IoT car ESP32, which is the microcontroller ESP32 will be the main controller for the all the component, and for the output we have used servo motor connected to direct to the microcontroller, and motor driver direct to microcontroller, while the two DC motor will connected to motor driver L298, and 12-volt battery supply will supply to the DC motor. And for the LED, we have connected to the ESP32 for the indicator of the speed of the car.
This is the 3D pictures of the project, which show the visual representation of the project from multiple angles, including front, side, and upper views. That's all.
Okay, for the discussion, okay, as we know, the IoT RC car project involved creating a remote control car using an ESP32 microcontroller and the Blink platform. And the user can control the car through a mobile apps or the laptop that communicate with the ESP32 over Wi-Fi. And as the LED speed indicator provide a visual feedback on the car speed, which adjusts based on user input, which is in the Blink application. And also from this project, we see there is a common error include using incorrect pin, power supply problems, and code related issue. So in this common error, we should careful pin selection and use a proper power management and through the code review to see if there is any error in the code, so it can help ensure successful project implementation. Okay.
Alright, in conclusion, the IoT RC car project using ASP32 and Blink was a successful attempt that created a versatile and interactive remote controlled car. By integrating ESP32 microcontroller, Blink platform, and various hardware components, the project allowed for seamless communication and precise control between users' mobile device and the RC car. The Blink app provided a user-friendly interface with buttons, sliders, and visual indicators, making it easier for users to control the car movements, adjust speed, and monitor servo motors direction. The LED speed added indicator added an extra level of visual feedback, enhancing the user's experience and improving the car's maneuverability. Despite challenges such as pin configuration errors, power supply issues, the project's success showcases the potential combining of IoT and mobile app control in the realm of robotics and automations.